Welcome to Escape Velocity Space News. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. This is our last episode of season 3. We're going to take off the month of August, and we'll be back with our next episode on September 3rd. And we're going to keep things short and sweet with this episode. Not a lot of rockets took flight these past 2 weeks. And we're trying to get this episode out the door before Allie and I head out to Tucson, Arizona, where our parent company, the Planetary Science Institute, is holding their yearly retreat and doing strategic planning. The future of science is currently at a turning point. The choices being made by the U.S. Congress will determine if the necessary funding for research continues to exist. And the administration's willingness to let any allocated funds be spent will decide not just the future of science, but in many ways the future of the United States. Here's what is happening. Agencies like the National Science Foundation canceled programs at the instruction of DOJ and the executive branch. Lawsuits led to courts instructing agencies to honor grant awards and continue funding projects consistent with congressional budgets. Unfortunately, universities are reporting that funding just isn't coming back. The court orders are, in many cases, being ignored. This is a situation without precedent. I can't pretend to know what the future will look like. So I'm meeting with my colleagues next week, and we're going to work together to try and figure out how to make ourselves resilient to whatever might be coming. And this is where I want to earnestly ask for your help. I live in a world where researchers are just trying to keep things going on half-time salaries and tightened belts for one to budgets of just a few $100,000 a year for entire research projects. I'm in the process of pulling together researchers around two major research programs, and I'm looking for people and companies interested in investing in seeing our science and the related educational projects become a reality. If you want to become part of our journey, please email me at plg@psi.edu. We're planning a Save Our Science Hangout-a-thon, October 10th through 12th, where we will be introducing our projects to the world. I hope to hear from those of you in a position to say, I want to see science funded. Take my money. And I want to invite you to be part of everything we're creating. For now, though, it's time to look at our latest science discoveries. Coming up next are a look at the outer solar system and all the strange things we're finding, including updates on an interstellar object, I3 Atlas. We're also going to be looking at Betelgeuse's possibly discovered little companion, which has been named Betelbuddy unofficially. All this and more is coming to you right here, right now on EVSN, a product of CosmoQuest and supported through our Patreon. Before we dive into this week's news, I want to just go over the structure of our solar system for a moment. Here in the inner system, we live in the land of rocky objects and cratered planets. While the largest concentration of rocky objects are gathered up at the asteroid belt by number, not by mass. It's the largest number of rocky objects. The entire solar system is actually swarming with rocks of various sizes. At the most basic level, an asteroid is just something that doesn't have ices on its surface that are causing it to grow a tail or a coma when temperatures rise. And they don't reflect as much light as an icy object out in the outer solar system. As we move out past Mars and into the asteroid belt, temperatures drop, and we transition from objects like Vesta that formed in wet conditions to objects like Ceres that formed in icy conditions. We start to see moons like Europa that are shelled in ice, and small icy objects that have names like centaurs and Kuiper belt objects and trans-Neptunian objects and sednoids. These small bodies are generally icy and would be called comets if they flew into the inner solar system. There's no hard and fast dividing line between an asteroid and an icy object. And technically, all these tiny things in the inner and outer solar system are minor planets and small bodies. And our solar system is capable of weird identity changing feats. The orbits of centaurs can evolve through interactions with Jupiter and other large planets, and these large chunks of ice can get flung our way and turned into comets. Comets can lose their volatiles and get coated in material and start to look like asteroids. And objects, including planets, can even get flung out of our solar system through interactions with each other and with passing stars. Beyond our solar system, there are perhaps more rogue planets than there are stars. And for every planet, there is likely a population of small bodies making their way through space. As telescopes get better, teams put more and more effort into mapping out what exists in our outer solar system. We keep expecting, or at least hoping, to find Planet 9, a planet that explains why so many objects are in weirdly elliptical orbits pointed in vaguely the same direction. But what if we instead found a bunch of objects in not aligned orbits and the need for a Planet 9 just went away? Back in May, we told you about the unconfirmed discovery of an object in the IRAS and Akari surveys that appears to be a potentially planet sized and several hundred astronomical units distant planet from our sun. Now, another team, another team has found another object in the outer solar system. This time it appears smaller, just a few hundred kilometers across, and its orbit carries it from as close as 66 astronomical units away to as far as, well, 430 something astronomical units away. This highly elliptical orbit makes this what is called a sednoid object, a category named after the object Sedna that is also in one of these weirdly super elliptical orbits. Cataloged as 2023 KQ14 and nicknamed Ammonite, it's totally not aligned with previously found outer worlds. Its existence seems to indicate a Planet 9 isn't necessary to explain the previously seen weird orbits. Rather, we need to just look in that other direction a whole lot more and see if there is missing stuff waiting to be found that will fill in that gap. Ammonite was found using the Subaru telescope on Mauna Kea, and this work was published in Nature Astronomy by a team led by Ting Tiang Chen. Meanwhile, across the volcano at the Canada France Hawaii telescope, another team was also looking for and also finding outer solar system objects. The LIDO survey found a new object cataloged as 2020 VN40 that orbits the sun once for every 10 orbits of Neptune. This is the first time anything has been found in a 10-to-1 resonance. And this is a pretty wild orbit. It comes in to 38.26 astronomical units from the sun, which is pretty close to Neptune in the grand scheme of the solar system. And then it flies all the way out to more than 240 astronomical units away. This is always further than Neptune, but it is close enough to Neptune's 30 AU orbit for Neptune's gravity to play a major role in its orbital evolution. According to project researcher Kat Vogt, quote, "This discovery helps expand our picture of how the orbits of distant objects are influenced by Neptune. It is the most distant confirmed object in an orbital resonance with Neptune, and the observed distribution of resonant objects provides vital clues to how Neptune and other giant planets rearranged themselves after their formation. This work appears in the Planetary Science Journal with lead author Rosemary Pike, and this work was funded by NASA, the National Science Foundation, and the National Research Council of Canada. One of the things that continues to amaze me is how much we still have to learn about solar system formation. Understanding how our universe seeded solar systems in so much variety is work it will take generations to fully understand. But we're making progress, slow and steady, in understanding big picture ideas. Just how you get planets so far out beyond Pluto has been one of those, but how enigmas. But researchers are finally starting to get a clear picture of what's going on thanks to computer simulations. A new paper in Nature Astronomy, led by Andre Isidoro, looks at how the planet on planet gravitational interactions in young solar systems can fling worlds outwards, while the gravitational interactions with surrounding star systems can stop those planets from escaping and stabilize them in far flung orbits. The paper estimates that 1 in 10,000 solar systems in general could have far flung planets. And a solar system like ours could have as high as 40% chance of flinging a 5 to 10 Earth mass planet into an ultra wide orbit, thanks to various forms of chaos associated with our two ice giants and two gas giants. Our solar system didn't form with just the objects we see today. There were once more worlds in our solar system. Some collided, like the young Earth and a now consumed Mars sized world called Theia. Some were probably flung away forever. And some probably just haven't been found yet. Here's to hoping the number of planets in our solar system someday goes up as a world or worlds, Earth sized or larger, get confirmed. I'm ready for that kind of a discovery. And Reuben will be just the telescope to make it. Up next, we're going to take a look at that interstellar invader, I3 Atlas, and Betelgeuse's possible buddy. Stay tuned. Growing up, I remember learning that comets could have elliptical, parabolic, or hyperbolic orbits. At the time, this was all about learning conic sections and ellipticity of orbits. And it never really occurred to me that all those comets on escape orbits had to go somewhere. And similar comets and asteroids from other solar systems also had to go somewhere. And our solar system counts as a possible destination. In a 2021 paper led by Marshall Eubanks, researchers predicted that around 7 interstellar objects could pass through our solar system every year. Most have gone undetected because we don't have the capacity to monitor the entire sky and calculate orbits for everything we see. Or at least we didn't. We're getting a little bit better. With Reuben Observatory, we'll be able to monitor the entire southern nighttime sky. And it's expected that with Reuben, we're going to start finding a regular parade of visiting interstellar objects. But I3 Atlas wasn't one to wait. This high speed icy object was discovered July 1st and made it into our last episode just under the wire. Since then, researchers have both taken new images with every possible telescope and turned up more pre discovery images that had I3 Atlas coincidentally in the background of images taken for other purposes. Our highest resolution images clearly show that I3 Atlas is surrounded by a coma of sublimated gases, and it's easy to call this a comet. Now, there are those out there who would like to claim this is a visiting alien spacecraft and use I3 Atlas's super annoying orbit as proof. It's not aliens. I3 Atlas is closest to the sun and most likely to be doing something interesting, at an unfortunately timed moment when Earth is exactly opposite from it on its own orbit around the sun. Our local star is the worst wingman ever and is going to make it impossible for us to get a good look at this scientific treasure from another solar system. But these things happen. The probability that a third interstellar object ever discovered would be this terribly timed isn't high, but it isn't zero. And in our vast universe, someone has to pull the short straw. And this time it was us. So far, we haven't detected anything out of the ordinary in the chemical signature of I3 Atlas. Observations by IRTF on July 12th saw colors consistent with D type asteroids and comet nuclei. When combined with Gemini spectroscopy, the coma is consistent with the presence of water ice. Looking at the object's current motion, some researchers have speculated that I3 Atlas could have come maybe from the outer regions of our galaxy's disk, the region we call the thick disk. If that's the case, it could have come from a system significantly older than our own. But there are some strong caveats on that possibility. First of all, it assumes the object's current trajectory hasn't been bent and warped by myriad past interactions with other objects. We also need to remember there's a whole lot of galaxy between us and the thick disk. And if I3 Atlas does have an unaltered trajectory, it could have originated anywhere between here and the thick disk, in another similarly aged star system to our own. At the end of the day, this object will tell us about what is possible in our galaxy, but it won't tell us about any specific place because we just don't know for certain where, other than not here, that this object came from. In the most likely case, I3 Atlas won't be out of the ordinary. Comets already come in a lot of different varieties, and it doesn't look weird. As it gets closer to the sun and brighter, we'll be able to get better data. In the most interesting of cases, we'll be able to see complex molecules never seen in locally formed comets. Or we'll see atomic ratios that indicate it came from a solar system that was produced by a different set of supernovae than formed the stuff of our solar system. It's also possible we'll see something super neat, but it's also possible this object will confirm that comets are comets and they come in a large variety, but that variety is pretty much the same everywhere. Time will tell. JWST observations are planned, and this is just the beginning of our research. I suspect we'll be bringing you a whole series of stories on this object over the next year, and I don't expect any of them will include news of aliens or of technology other than our own. In other news, last December, a paper in the Astronomical Journal led by Morgan McLeod used decades of data we have on Betelgeuse's changing brightness to predict that the star has a low mass companion, possibly still in the process of forming. That object was predicted to orbit every 5.775 years. As luck would have it, last year was when the companion star should have been well separated from Betelgeuse on the sky. And a group of astronomers led by Steve Howell was able to get telescope time on Gemini North to see what they could see. And they quite possibly saw a blob that could be the predicted star at roughly the predicted distance from Betelgeuse's surface. In a rare moment of excellence in naming, this blob is being unofficially called Betelbuddy. Betelgeuse is a massive star that is closing in on the end of its very short life. In the next tens of thousands to hundreds of thousands of years, it will explode. And assuming it's the right time of year, we might even be able to see that supernova as a daytime object. In star forming regions like Orion, the largest stars will actually live and die before the smaller stars get their mass together and start fusing hydrogen. And this little star has not yet got its stuff together. With about 1.5 times the mass of our sun, it has the potential to become a hot, bright star one day. But instead of doing that, It's just gonna get eaten. Currently, Betelbuddy is orbiting in the outer layers of Betelgeuse's atmosphere, and drag from the atmosphere will pull Betelbuddy into Betelgeuse, where it will get torn up and devoured if what we're seeing is real. This is a super low signal detection, and it could easily be a false detection. Unfortunately, they didn't get enough different nights of data to see the object clearly orbiting. And the images were taken while Betelbuddy was heading closer and closer to Betelgeuse on the sky. This New Year's, when we look at Betelgeuse shining from Orion's shoulder, we're going to see it and Betelbuddy pretty much as close as they get on the sky. And we're going to have to wait until 2027 to see Betelbuddy again if it's there and if it comes far enough out of the glare of Betelgeuse when it's not up during the day. What is wild to me about these observations is how many people have observed Betelgeuse with so many different extremely high resolution systems without ever seeing this buddy before. Part of this is just the bad luck of how the orbits align in time. Around 4 out of every 5.775 years, Betelbuddy is lost in the glare of Betelgeuse. We can only see Betelgeuse part of the year because of our orbit around the sun. This combination of our orbit and Betelbuddy's orbit make observing Betelbuddy annoyingly difficult. That next time Betelbuddy is easiest to see, it occurs in the summer of 2027. I'm just hoping Betelbuddy is far enough from Betelgeuse in the spring and fall that it can be seen and its motion can be observed. Up next, we're going to consider things available to see right now, specifically the August meteor showers. Stay tuned. Normally, this is where I'd be introducing on Erik to talk about all the cool things that launched this past fortnight. The thing is, the past 2 weeks have been pretty boring when it comes to rockets. There was a scrub due to a glitch in Sacramento's air traffic control system, and that scrub was really about as exciting as it got. We're starting to reach a point in history where constellations are getting launched with an ease and regularity akin to what I expect of departing FedEx planes. Rocket News will be back with our first episode of the new season. And for now, I'm going to say go out and take a good look at the chaos that is the night sky in early August. I'll admit my normal thoughts of camping out are getting canceled as I look at the heat advisories here in the Midwest. But one of these nights, I'll be out there in my hammock under a layer of bug net, watching the midnight sky for streaking meteors. The Perseids are best viewed on August 12th and 13th, but can be seen from now all the way through August 24th as the Earth passes through debris left behind by Comet Swift-Tuttle. Overlapping with the bright Perseids is the southern delta Peried Meteor shower, which peaks on July 30th, but is visible until August 21st. The source of this latter meteor shower isn't known for certain. Both showers are best seen late at night, but I'm going to issue you a challenge. Saturday, August 23rd is new moon. That night and the nights around it will be moonless. I want you to go out at sunset and watch as the sky darkens. Let yourself get beguiled by fireflies that will make you think the brightest meteor ever is streaking through the trees until you realize it's a bug. And then let yourself feel whatever it is you feel as you see satellite after satellite streak by overhead. I still remember the first time I saw a satellite with my own eyes. I was camping in the mountains and had gone to sit on a rock and be a moody teenager in the 90s in the dark, the way only a moody teenager can be. There wasn't a light to be seen for miles, but the stars, they were amazing. And when one of them moved, I held my breath until I realized it wasn't a star, it was a satellite. But the last time I tried to see the Perseids, the fireflies and the low Earth orbit satellites were far more numerous than the shooting stars. And trying to do early evening astrophotography just wasn't possible for all the starlings buzzing past. We're losing the night that I got to see as a child and moving towards something from Wall E. While we can still see stars and meteors and fireflies, go watch the night, beginning to end. Before we go, I want to share one final thing. This month marks the 10th anniversary of the New Horizons spacecraft making its historic flyby of Pluto. The mission is still healthy and still being used for science and has recently demonstrated that astral navigation is possible even from inside our solar system. From its location in the Kuiper Belt, it has been able to measure shifts in the observed locations of nearby stars compared to background objects. And researchers could use those shifts to calculate the mission's position. Well, it is way easier to use techniques like measuring light travel time of radio signals and such. It's cool to know the stuff of science fiction is now becoming a modern day reality. The New Horizon mission is one of the nearly 2 dozen functional spacecraft the president's budget seeks to decommission. If you want to see more objects visited and more science done by New Horizons, call your representatives and ask that they fund space science. That's it for now. We'll see you in September. Good night, everyone. And remember, go out and look up.